At the Air Force Research Laboratory, we're pioneering fundamental new advances for a number of the technologies that you live with every day. AFRL contributed to innovations like the Internet, the compact disc, and speech processing and understanding, which initiated the early developmental years of Siri. We continue to think big. Now we are driving innovation for what will bring the next profound technological evolution. Quantum technologies will bring massive change, and moving to software-defined, agile communications is about to expand the limitations of current technology in new and previously unimaginable ways.
Hello, I'm Major General Bill Cooley, the commander of the Air Force Research Laboratory. AFRL invests in a number of technologies for the United States Air Force. One of the emerging technologies is quantum information sciences. Quantum information science enables a whole number of capabilities that our Air Force could use.
Recent advances in quantum information science will lead to disruptive advantages for warfighter capabilities in the areas such as timing, sensing, communication, networking, and quantum computing.
These areas exploit two different properties of quantum mechanics. One is called superposition, where particles can be in multiple states at the same time. And then the other one is entanglement, whereby particles are perfectly correlated with each other, sort of like a global sharing of information, where the measurement of one particle affects another particle, even if they're spatially separated.
If you're able to distribute this property called entanglement, you can actually do fundamentally new things in a network beyond just the standard communication protocols that we think of today. One of those might be something like teleportation, where you could actually teleport information from one quantum system to another without having to go over a classical channel. This would go over a quantum channel, and so that makes them even more secure because no one's able to access that channel except the parties that have the entanglement shared between them.
Quantum technologies can be applied to develop inertial navigation systems or precise timing systems.
The state-of-the-art atomic clocks are accurate to 1 second over the age of the universe, but that takes up optical table size, large meter-sized scale. But imagine if you could shrink that down to cell phone size and then put that on a plane.
That is what the Air Force Research Laboratory is pioneering, the ability to get 1,000 times better GPS accuracy in a device with extremely small swap space.
Precision navigation and timing is one of the key enablers for knowing where you are and what time it is. But quantum offers the promise not just to be able to do that in a GPS denied or degraded environment, but also do it with unprecedented precision. And that precision can allow new generations of distributed sensing capabilities that today simply aren't possible.
For sensing, what we're using is the exquisite control over two atomic level systems. So you can use that to look for underground bunkers, for voids, for detection of nuclear materials by disturbances of these energy levels.
Quantum promises to revolutionize cryptography in terms of quantum computing, and we are looking at multiple ways of doing that with photonics and trapped ions.
The goal is to have long-distance quantum communication. This adds a level of security to your information by operating at the single particle level. But in order to do that, what you need is quantum memory.
An ion provides memory and the ability to process.
Photons are one of the ideal carriers for quantum information systems. They're also the ideal carrier for long-distance transmission of quantum information.
This gives rise to things like exponential computing speeds for certain problems and the ultra-secure communication protocols for networking.
And so as we try to provide assured communications in a contested environment, quantum technologies may be one of the ways we deliver that. As one AFRL, we're bringing in expertise from across the laboratory and across the nation to bear on this problem.
We seek interlocked partnerships to streamline innovation and provide disruptive capabilities.
QCware is a quantum computing software company based in Palo Alto, California. AFRL and QCware have pulled together a world-class group of physicists, algorithm experts, and mathematicians who are exploring ways to use quantum computers to resolve Air Force computing bottlenecks in optimization, simulation, and machine learning.
SUNY's world-class research and facilities in quantum materials, devices, networks, and systems are unparalleled. Together, we are developing a culture of discovery and building unmatched capabilities to deliver quantum solutions and develop a quantum smart workforce to enhance our national security and economic competitiveness.
Team with AFRL as we push the boundaries of the possible and define the future.